Welcome back everyone. We're here again today with our third installment of our online vectors series, and in today's class I want to do a quick recap of some of the things that we would have learned in the last two classes by going through these two questions, and then I will continue our notes on vectors, which should include equal vectors, opposite vectors, parallel and collinear vectors. So in our first question it says the 3 points A, B, and G are drawn on a graph. Now the question gives me points A as -2 and 5 and B as 4, 2. It says the origin O is the point 0, 0 and the point G lies on the line AB such that AG is 1/3 of AB. And this question, they were so nice to give us a sketch. We are to answer some of the following questions. Question 1 is to figure out OA, the position vector OB, the displacement vector AB and AG, and finally, as a bonus question, we're to calculate the position vector OG. So let us begin. First thing, if you remember, to convert any coordinate to a position vector, we simply convert the coordinate into its column vector form. So the answer for OA should be -2, 5. And remember to put your brackets to represent that it is a column vector. Likewise, for OB, if you come from the origin and you're going to B, you're going to travel 4 across and 2 up. And this is represented by the column vector 4, 2. So those first two are always straightforward. You convert the coordinates into their column vector form. Now we move on to the vector AB, which will be this line here from A going to B. Now we don't know the vector for this and we're asked to calculate it, but we do know how to travel from A to O and then from O to B. So if you remember, your vector AB is the combination of A to O plus your vector O to B. Alright, so to represent this now as a question, you must remember that A to O should be the reverse of OA. So what we do, we change the signs of OA. So instead of putting -2, I will put +2, and instead of having a +5, I would have a -5 because we're going in the opposite direction. And OB stays the same, so therefore I'm just going to add 4 and 2 onto this, and my answer should be 6, -3. Alright, so this will be the vector AB. 6, -3. Now AG. Let's pause a minute and go back to the question to see what it gives us about AG. Now this is why it's important to read your questions carefully, because in the question it tells us that AG is 1/3 of AB. So we must use this information to help us solve for AG. So the simple answer to this would be that AG is 1/3 of the vector AB. So if I were to represent this as a column vector, I take 1/3 of my previous answer. So 1/3 of 6, -3, that answer should be 2, -1. Okay, so I simply took 1/3 of my previous answer. Now on to our final question. We're asked to calculate the position vector OG. Now we do not know the direct path to go from O straight up to G. However, we do know the route which will take us from the origin O up to A and then from A to G. So to express this vector in an equation, I would write OG is equal to the vector OA plus the vector AG. Now to calculate it, we know what OA is, and that is -2, 5, and AG, we just calculated it as 2, -1. So therefore, by adding these two together, I calculate the position vector OG to be 0, 4. And it almost makes sense based on our diagram here that G is directly above O. So we just went 4 spaces up and we didn't go left or right. Therefore, that's why the top part is 0 and the bottom part is 4. Now moving on to the next question. Now in this question, we're not going to use numbers as much. We are actually going to represent our answers in terms of the vector paths A and B. Now just to jog your memory, if you have the vector P, the path to get from O to P is called A, common A. Likewise, the path from P to G is the common letter called B. So we can represent the vectors themselves by these common letters, which we call the vector paths. So the question itself reads, the triangle OGP is drawn above, and it's not drawn to scale. M is the midpoint of OG. The vectors OP is represented by A, and PG is represented by B. Now we're to express all of our answers below in terms of A and B. And the first question is, calculate the vector OG. Now looking at our diagram, if we start at O and we want to go to G, we must first travel to P first and then from P to G. So to represent that as a vector path, it would be the vector path A plus the path called B. Following on from that, we are asked now to find out the vector OM. Now it says in the question that M is the midpoint of OG, meaning the halfway point of OG. So if I take my previous answer and I divide it by 2, that should give me my answer for OM. So I can take the previous answer, AB, and divide it by 2. Now in most cases, it may be more appropriate to write your answer like this, where you have A on 2 plus B over 2. Either or you would be correct, but it might be better off to just represent your answer like this. Now in part C, we're asked to find the vector GM. And to do this, we have to use a bit of logic. Now in the previous question, we calculated the vector OM, and that was going in this direction. Now GM will be the vector starting at G, going to M. And remember, M was the midpoint. Therefore, G to M should be the same vector as it was from O to M, but in the opposite direction. So my answer from G to M will be the same as the one above. However, I must remember to change the signs of my vector paths. So instead of writing A, I will write negative A on 2 plus, and I would write negative B on 2 to represent it going in the other direction. Alright, now finally we have D, which is the vector PM. For this last question, it's actually quite possible to solve it using 2 different ways, but you should get the same answer at the end. Now if you start at P and you want to go to M, it is possible for you to travel from P to G first and then from G to M. So to represent that, I would write B plus my previous answer, which is negative A on 2 plus negative B on 2. Now I can simplify this a bit further, and I can add this B. I'm going to write a 1 in front of it so you understand is 1B plus this negative half B. So 1 take away a half, you should know is a half. So my final answer should be negative A on 2, because that stays the same, plus a half B. Now that's one way of solving it. Now if we start over that question and I start at P, I could have also gone the other direction where I go from P to O and then from O to M. Now remember, P to O is the reverse direction, so that would be represented by negative A. And we worked out O to M in question B, and that answer was A on 2 plus B on 2. So negative A plus a half, again this is negative 1A, and you're adding a half to that. So when I simplify, my answer should be negative A over 2 plus B on 2, because that should stay the same in this case. So you get the same answer no matter which direction you travel in once you add the vectors together. Now to finish off our notes, let's simply talk about what are equal vectors, opposite vectors, parallel, and collinear vectors. Now, you say that two vectors are equal if they both have the same magnitude and direction. So that's pretty straightforward. In the example shown here, you have vector AB and then you have vector PQ, and they both can be represented by the same path called C. Now, two vectors are opposite if they both have the same magnitude but they are traveling in the opposite directions. So as you can see, if one has a path called B, then the other must have the path called negative B. Simply remember to change the signs if they are opposite, but they must have the same magnitude. Now next up, we have parallel vectors. Now I'm going to slow down a little bit just to make sure everyone is clear. Two vectors are parallel if they both have the same direction. However, their magnitudes may not be the same. And in the example, you have vector AB, which has a path called B, and then you have vector CD, which has a path called 2B. I mean, it is pretty obvious that CD is twice the size of AB because of the 2 in front of the B. But because both of them have B and nothing else, that means that they both have the same direction. So these two vectors are parallel. A simple test to check to see if two vectors are parallel is to simply determine if one vector is just a multiple of the other, a scalar multiple to be exact. Now we're going to bring the point home by trying this simple example where you have two vectors, the first one being B, and it tells us that B is 3, 2 and C is 12, 8. And we're going to prove that these two vectors are parallel. And we do this by writing a simple statement that says if B equals to 3, 2 and C is equal to 4 times B, which is equal to 12, 8, then it stands to reason that B is parallel to C. And that's how you would answer a question like that. And finally, for this class, we're just going to touch on the topic of collinear vectors. Now it says that two vectors are collinear if one vector is a scalar multiple of the other vector. So pretty much similar to how we were doing with parallel vectors. But it also implies that if you have a vector AB and a vector BC and they are collinear, then that means all 3 points A, B, and C are on the same line, or they lie on the same line. And usually when you're answering these questions, your goal is to prove that, for example, BC is a multiple of AB. We're going to touch on this in the next class, but I hope you enjoyed today's video. Feel free to like, share, and comment below. You can always visit us at knowledgescroll.com, where you can look at our full list of services that we offer to secondary and high school students. Here's also where you would come to browse our full catalog of featured videos, as well as sign up for any of our reasonably priced online courses. My name is Kevin, and I thank you for watching, and I hope we meet again.